Okay, it seems it's not working. Okay, so
Hey guys, today I'm going to present a review presentation on a research paper. The research paper is called Multimodal Machine Learning Survey and Taxonomy. The reason I'm doing this review presentation is because this paper actually helped me a lot to progress with my project. Okay, first let's try to understand what multimodal machine learning is. We say a single modality is basically like hearing, like audio, image, or something like that. That's a certain kind of modality. Multimodal is basically the mix, like video information, audio plus image plus photos or something like that. Now we have a lot of challenges in doing this. This is not easy. And we have usually 5 main challenges. One is representation, translation, alignment, fusion, and co-learning. So let me explain to you what these 5 are. Okay, first challenge is, in my project, the first challenge is representation. Representation is basically how you represent and summarize the model data. How are you going to represent the data? Like, for example, you take an audio file, you convert it, you bring it to some form. You take an image file, you convert it and bring it to some form. Now this some form is not the same for audio and the image. So if they are not the same, then how do you represent it? So this is the first challenge. So the second thing is like homogeneity of data, which is obvious. Audio files are obviously different from video files and image files. So there is a huge challenge in representation. Usually there are 2 types of representation. In this kind of situation, we go for either one of those 2 types. One is joint representation and the other one is coordinated representation. Now, what is joint representation? In joint representation, there is a semantic space. We send an audio file in my project. In the situation of my project, we send the audio file, we send the image file, and then we project them to the same space. Okay. So here we usually use a neural network with hidden layers, and then we we project them to the same space. Like for example, like we can see the x function, x of m is equal to function of x2, x so on xn. Let me show you the image. So this is joint representation. We have a lot of modalities. In my case, we just have two modalities. One is the image and one is the audio. In this case, there are many kinds of modalities, and all of them are represented in the same space, as you can see. This is called joint representation. The major advantage of neural network-based joint representation comes to their superior performance and ability to pre-train the representations in an unsupervised manner. This is the kind of representation which I'm going to use for my project. Now let's talk about coordinated representation. Coordinated representation is something where they are not represented in the same space, but they can be related through some kind of relation. Function of x1 is somewhat related to function of x2. So we coordinate them through some kind of distance. To give you an example, let's say the distance between an image of a dog and a text dog. It has the least distance. It has lesser distance than image of a dog and a text cat. Are you able to understand? There is an image of a dog and there is the word dog. These both have lesser Euclidean distance than image of a dog and text cat. They have more distance. So there is a relation between these both. This is called the similarity model. This is called coordinated representation. Now this is how it's done. Like this is represented separately, this is represented, but they can be correlated through a representation. Like for example, some kind of distance between the points. It enforces more structure on resulting space. Here again, neural networks are the best way to implement them. But I'm not going to be using coordinated for my project. And translation. This is the second challenge, as we have seen representation. Now we go to translation. Translation is the second type of challenge we have. Now translation is, okay, now we know how to project them in a semantic space. Now the problem is, how do you map them? How do you know that this image file corresponds to this audio file? How do you map them? Now that challenge is called translation. Okay, there are different ways to map them. Now we are going to look at that. And this is one of the major problems faced by me. First thing is, one way to map them is called dictionaries. We all know what dictionaries are in Python. Okay, but here it's not just any simple dictionary. We have two kinds of dictionary. One is the example based and one is the generative based. Now the example based dictionary model. In this case, we just map them through some kind of logic, like the text dog and the image of dog. We already know that it's a text of a dog, it's an image of a dog. So we just map them, and using this we build a model. So we use some kind of algorithm, a very basic algorithm, in case wherein we just enter the input data and get the target data. It's like night bias in this case, except it's a dictionary. Are you able to understand? Yeah. This is very simple one. This is like not used for practical applications. This is very simple. Generative based dictionary model is used in practical applications where we have a dictionary and we build a translation model out of it. Now we send the input data to a translation model. We use this for training. So from the input data, we send it to the translation model, and then we get the output. So in this case, the system is more intelligent. It learns progressively as you train it better and better. Now we are going to compare both types. As usual, you know, this is very basic. This is more advanced. In example-based, the algorithm basically relies on finding the closest sample in a dictionary. Here it first trains the model on a dictionary, then uses the model. It's easy to build, more difficult to build, obvious. Yeah. Now we come to the third challenge. The third challenge is called alignment. Usually alignment, I don't face this challenge because I don't deal with video data. Video data, for example, what is alignment? For example, there is a movie and there is a subtitle. Now the subtitle should come correctly when the guy is speaking. Like if someone is speaking, this subtitle should appear correctly. So this is called alignment. You don't want the subtitle to come 10 minutes later after he has finished speaking. So that makes no sense. So in my project, which is basically speech to text recognition, In that case, I'm not going to read any movie file or something to get it aligned. Okay, fusion. Fusion is very important for any good model, for any good neural network model or anything. It basically deals with working with missing data. Okay, it gives access to multiple modalities. It can still operate. This is the second point, is like really most important point. Using fusion, the multimodal system can still operate when one of the modalities are missing. In my case, like for example, if I'm giving image input and audio input, sometimes I won't have both, one of them will be missing. In that case, fusion helps us a lot. The multimodal system has to operate when one of the modalities are different. So in my case, like digital image is there, audio of the digital is there, it can work even with just exactly one of them missing. With both of them missing, it's not an input, it's just zero. Okay, in fusion there are two types of fusion. One is model based and second one is model agnostic based. Okay, we don't use model agnostic because they don't cope up with multimodal data. They can be used in any unimodal classifiers. Like you're going to only work with images, not with audio. In that case, model agnostic works. Um, it makes predictions easier when one of or more of the modalities are missing, and it even allows for training for more parallel data is available. Um, okay, so as you can see, we can see a word called late fusion. Okay, so let me explain to you what late fusion is. Late fusion is like when we have two kinds of data and one of them is missing, and then we feed it and then it gets a prediction. Now late fusion is it fuses both of them after the prediction is made. Now there is some kind of model called the early fusion model. In this early fusion model, the thing is when it is entered inside, it predicts before itself, beforehand itself. Then it tries to fuse. So in this case, it's just model agnostic. It is not so much relevant to what I'm doing. Okay, co-learning is very important. Co-learning is basically aiding the modeling of a resource-poor modality by exploiting knowledge from another resource-rich modality. Suppose the audio input is very noisy. Suppose we can't get proper data out of it. It's just too noisy. In that case, we can use the strength of our image recognition to compromise this. So this is called co-learning. In co-learning, we have something called parallel co-learning, which you have an image data set and the audio data set. In this case, we just train both of them together by matching. Okay. This is non-parallel co-learning. This is a more advanced type. This is what is being used. This is what is supposed to be used. We have an image data set, we have an audio data set. Now we need to have some concepts. This concepts is nothing but we need to find a pattern in the audio and the image. We need to find a pattern. Like for example, if we say number one, number two, all these have a certain pattern. So with this pattern, we try to correlate and then start the non-parallel co-learning. We have the hybrid co-learning as well, which is very similar to non-parallel. It's just a mixture of parallel and non-parallel. We just mix both of them, we get hybrid. So, so as for co-learning, I really don't know because I have not proceeded to that stage. In fact, I have not started a representation as well. But one thing is, from this paper, Multimodal Learning Survey and Taxonomy, what I really found out was joint representation is the type of representation I'm going to make. Generative based dictionary model is my goal. I will start with an example based dictionary model, make it simple first, then try to implement more and more changes wherever it could be, because example based is first easy. Let me just first figure out what is going on. Then generative based dictionary model will be implemented, and late fusion model agnostic model. In this model agnostic model, the thing is like late fusion is a particular type of agnostic model wherein each of the modalities, like the integration after each of those modalities have been happening. Like I told you, like if one is missing, it predicts without one of the modalities. So first, I would like to implement this late fusion model, agnostic model, and try to get some results out of it. Then I will proceed to uh, co-learning. Co-learning, I'm very unsure for the time being because co-learning is a different challenge. Um, I have not proceeded much into my project to find out what other unpremeditated challenges are waiting. So far, this is what I've obtained from the knowledge of the paper. And in general, the result of a good model is it should combine the data from heterogeneous sources. Like you should not only like take very simple data, like just like heterogeneous sources, like what do you say, like for audio, image, and you should take this data sets from different places with noise. So you should combine the data and deal with different levels of noise, yes, obviously, and deal with missing data. This is very important. So with the observed data, we should build a model to deal with the missing data, and representation should be easy to obtain even in absence of some modalities. As I told you, as I was speaking, when one of them is absent, we should be able to predict with the other. So this is how a good model should be. Yeah.
You could have some requirements about accuracy of your model.
Accuracy of my model. My aim is to improve the accuracy. I don't know how much accuracy I'll be getting, but my aim is to improve because as you can see, like I don't know what kind of co-learning I will be doing. I don't know which kind of model I will choose. So the accuracy I'm trying to achieve uh, maybe about 85 at first to start with, because practical models need more than 95.
What models do you plan to compete?
What product I'm planning to compete?
What models? I mean, there are some only sound prediction models. I mean, sound recognition in the word.
Okay, I'm trying to create a speech to text recognition where the inputs are an image of a digit and the sound of a digit. So this is going to help small children learning because small children like visual learning rather than just books and whatever. At the same time, it will also help deaf people. If someone speaks in audio and then the image is there, so he can read the text. It will help in education. At first, I'm going to start with digits, training with digits. Then later it goes towards
there is already single speech recognition, for instance. Maybe this, maybe you could just apply the coordination between Google speech recognition and the image. I mean, any image recognition model.
but they are not open source. They are like what do you say? I mean, they are open source, but like uh, the thing is like I'm trying to build a specific representation. I'm trying to build a complete project here, like with the joint representation of images and audio, which is actually it's based on mixed channels. You know, mixed channels, right? So it's the whole system together. It's not only the output. Like it's not like you're just converting speech to text. It's the whole system. I'm going to like apply it somewhere.
One of the advantages was that it's easier to apply retraining. Why? What's the difference between joint representation and other ways in this training?
You're talking about this one, right? Um, okay. What was your question?
Why?
Why is it easier to? Why is it has superior performance? Okay. it has superior performance because in coordinated, we insert a similarity, we insert a constraint. Like between, like for example, the image of a dog and the text dog, we insert a similarity. In this case, we try to manually coordinate these both, and the system will start working on that.
Okay, so I think I didn't get it. So
we have an image of
better in coordinated simulation, right?
Well, I don't understand.
We need retraining in kind of representation, right?
Pre-training is basically on this, on joint. In coordinated, we, like for example, you have an image of a dog and a text dog. We try to bring these both together.
Yeah,
in joint, we don't try to bring them. We just keep them. The machine it learns based on both. Okay. Question.
Model, parallel model that hybrid is parallel plus serial. Isn't it just hybrid, like, yes, different coloring and parallel coloring? Are you sure that it's like parallel, hybrid is parallel plus serial? Isn't it like one version of parallel plus another version of parallel?
Yeah, but yeah, it's not like parallel. It's not like you're doing parallel and non-parallel together, and then that's called hybrid.
So no, I mean everything should be like one kind of parallel and have non-parallel parts. Everything, but you say that hybrid is parallel and non-parallel.
No, it's like a mixture of both. It's not like you're doing both simultaneously.
I mean, like, coloring can be. Coloring has some parts of parallel and some parts of non-parallel, but it doesn't makes it like. It doesn't make it like hybrids. I mean, there are several versions of how making parallel. So, if you use some methodologies of parallel, then it could be hybrid, isn't it?
Yeah, hybrid is like, for example, you have this data set, right?
Yes.
You directly train the other data set with this one. Okay, and if you see non-parallel, we relate all these elements of this data set through concepts to train the second one. We use all of them, pass it to a concept. You understand, right?
We don't use
No, everything means like, okay, leave the diagram. Everything means like we have a relation. We bring this to a relation, both of them to a relation. Okay, like how do you say, if you have an audio file, and then we bring it like like liters and kilogram. You take liters in one side and kilogram in one side. How do you relate them?
in case of water, in case of water.
We bring them to a similar. We bring them to a similar unit. Then we correlate like meter cube per liter. So that it's a very basic example. There is no learning on that, but it's something like that. We try to bring both of them to a similar thing, and then we use non-parallel. In fusion, both will happen. In hybrid, both will happen. Like we don't have to bring everything to what do you say, through a similarity. Like one can be directly matched. One you have to bring it to a similarity and then bring it.
How should help?
I don't know which co-learning I'm going to use. I've not proceeded to that state.
But I mean, why do we need it at all? Not specifically in your case, but in general.
How do you relate two different data sets of different types?
No. I mean, why it is not enough to use only parallel or non-parallel? Why we could at all in general need hybrid coloring? Surprisingly, it's not an answer in science. So that was my question about.
Okay. Like if you have two different data sets of different types, how do you relate each of the data?
Directly, like in parallel, for instance.
Will that give you high accuracy?
What?
By directly relating them, will that give you high accuracy?
So then we use non-parallel. Adding the concepts and correlating through the additional entity.
Okay. Now, what if we have some slightly more complex data with more noise, and your system is able to say that this thing has noise? So what do? You have clean audio, you have clean image. In this case, both are different. Like you said, we have to do non-parallel. But what if we have an audio file which has too much noise, and your system is able to say this has noise? What do?
We should or exclude it or clean it.
Clean it. When you clean it,
Depending
you're
on
going
what
through
you
that.
do.
This is where hybrid comes in. Your system finds out that this has noise. So we clean it, then we train it with that one. You understand, right? When it's a clean audio file, we use non-parallel, like you said. When it's a dirty one, we need to clean it, then use it with the digits.
But then we use non-parallel again. It only adds us reconfiguration of data, preparing.
This increases the accuracy even more than non-parallel.
But I mean, after cleaning, we could still use non-parallel, and there would be no problem. For real, non-parallel could include could describe parallel dependencies. Because if you use a single concept to correlate between single entity in first data set and single entity in second data set, it is actually a parallel dependency. But it is still non-parallel. I mean, by the construction. Because now hybrid seems to look like more difficult, more complex, how to say, more complex, I forget, representation of non-parallel.
Okay, suppose you have an image of a woman. Now this woman is in a bus.
Woman.
So there is a woman.
Okay.
The woman is standing in a bus.
Oh, okay.
Okay. Now you have this instant, I read another research paper where they had actually tried to fill in the context of a sentence with missing words with the environment. Like if the woman is in a bus talking to someone else, it is something related to travel. I read a research paper on this. Like, do you understand?
I couldn't understand how it is.
I'm coming to that. I'm coming to that. Like, if the woman is in a bus, then the conversation is like something. It's a conversation which usually happens in a bus. So they try to train the system. Now, if the woman is in an airport, the conversation is like something relevant to an airport. Not about the airport, but something which happened within an airport.
Yeah.
Okay. Now, what if I tell you the woman is standing in a bus? Now the bus is in an airport in the image. Now, what would you do? In that case, you would try to find the dominance, right? Which is more dominant, the airport or the bus? So that's where this comes in.
And why? How it goes from the example you showed us. You explained.
Actually, like I don't know what type of co-learning I will do, but this is what hybrid co-learning is. According to my project, I don't know which type of co-learning I will do.
We know that the context of a situation adds more information to the policy.
Yeah.
Yeah. In speech recognition technologies, it's real challenge. And as for Google translation, you uh, run in Google Speech API only in the cases when you use mobile phone. That's why the domain of this speech is restricted, and they can include the question is about other situations in which we take video or sound surrounding.
It's quite clear, but it's not clear to me why we need to include both dependencies, parallel and no parallel, non-parallel and hybrid model. Because it just looks like we took the representation of non-parallel and made it more complex with parallel dependencies.
Yeah, depends on the type of data you're working. If your data is more complex, we need to add some more complex system.
It's like epsilon networks. They add some complexity to it. It seems like any neural network could just have learned this. Um, well, could have learned this, but to manually add this instruction, it may help.
But if doesn't, that's in that current situation, adding to non-parallel.
How do you know that?
No, wait. I would not think. Adding parallel dependencies into the non-parallel learning model doesn't increases its resolution. It only increases the complexity, but the resolution still is the same because you could represent parallel dependencies through non-parallel paradigms.
Depending on the implementation, could
Less
I don't understand. Okay.
other positions. What to improve in the report?
I didn't get the model agnostic and model there's two terms that and correct on the model.
We don't use model based as they don't pop up with. I'm using model agnostic. I'm using model agnostic late fusion. I don't use model based because they don't it's not for multimodal data. It's just for unimodal data. Works only with unimodal data.
The thing is, I just didn't get what's the difference between model based and model based. I do understand that it's for another slide describing model based would be like in the previous slide. You showed us two types of fusion, and then
yeah, I go for model agnostic. Yeah, I don't go for model based because this is not a full review of the paper. It's a review of the paper with regards to my project. How it helped me. The paper is actually quite big. There are a lot of information there, but just talking about some review paper of some research paper is not very helpful. It's helpful in like if you talk about how it impacts on your project. That's why I've written only about model agnostic.
Other suggestions to improve the
First, it's to increase the size of text and reduce the quantity of text per slide. So,
Just like 1 or 2 slides.
it already, how to say, messes. For instance, at least me.
Okay.
other.
The second one is maybe to add some structure, and some conclusion of all you said into the single image or scheme or something like that, so we could see the whole, say, the whole system, the whole idea as you could see it,
Okay.
as you
Sure.
imagine it.
Okay.
In your head.
Thank you.
Okay, so I see that the report is much more active for the audience. Now, as for other
Participants, did you schedule your particular messages? No? Yeah. No. Next time we will listen to our public speech training, and we need to give our requirements for this performance. What we really need. She asked me the technical requirements. I want you to suggest one. What we need to during 2 hours. She will train us, and what we need to remember. Yeah. We have not so much time to think about because she needs to prepare. Next time it will be 6th of March. Easy. We need to send our requirements for Friday evening. Now it's the time to suggest. And the second topic I want to discuss with you is our project and teamwork during this semester. I have an idea. We involve you in project activity with machine learning. So, as for public speaking,
I would really love some guides how to create a good presentation.
How to create a business.
Some, how to say, list of advices, what you should definitely do in your presentation to make it good. And maybe
Scientific
regarding the goal of your presentation. Yeah, because first I think she announced.
What was the purpose of if it was an idea to sell us, it was the most important thing about it. If it was like just to show everything there is, so basically it means that there is no you should like understand very well whom you like present your.
I think the very first thing public speech trainer would say about the how to create good presentation is what you said. But it is the very first step. And there are some
Very first step to understand
what
what
you
you
want
want
to
to
achieve.
Okay,
So it is
It's
this
an
is what
answer.
we know already. And there are a lot of things we don't know, but the good speaker
To understand
Yeah, what kind of presentation? Presentation for international conference or not seven, maybe seven, no.
elevator pitch.
Okay.
We should be focusing maybe on a bit more like thesis defendants kind of presentations. Because we will be applying in reality for our work.
Other ideas?
Depends on how much time which you spend in this. For example, this 2 hours.
Maybe on literature review. Literature review. When we make a presentation, when we reference websites or something, that time we can understand in what kind of basic format it should be given. How we reference them.
How to prepare a book?
I think it's very important also how to know how to manage the crowd. To keep again like your audience interested.
Okay, and maybe some practice of your theory.
yeah,
Various in groups, and for you to judge whether it's good or not.
actually I was just thinking about what at all you could do as a public speaker. So many examples of some stuff that was working like a public speech, and in that case we could practice on that. Somebody goes to the blackboard after the trainer explained what is that thing and try public speech in that style, in that manner, or something. Just like that.
Okay. waiting 2 hours.
It is working quite like that for the presentation as well.
Okay. So, we, okay, that's all for public display. And my idea is to make teams to work on critical tasks. Yeah, we can check which competitions are open, and also I can suggest particular task, not from table, but from current project, and it's completely defines what we need to achieve, and we have funds, so we can grant not only winners, but second and third place on this competition. So we can in some scope we can really set the line in spite of tables, because in table we have split deadline and completely complex task. Also, we have I know that many hackathons were open during last year. Open data science initiative. So, is it a good idea? If we decide about whether it should be I can provide with workstations, with video cards, processors. We can use our infrastructure in these competitions. I suppose that this activity is quite let's say it's not obligatory, but we have to do such an activity during our master program, because you need to be data scientist going to require such skills that I need to do such activity, and it is a good practice. So I can suggest different forms of participating in our seminar, and close to such a decision that for those who are participating in the table, they will quite fast. Faster, not faster. Another form is to present two, maybe three times. Present your work, your sample. So for those who don't want this activity, for not to making it so difficult, I suggest this.
There is a question. We just started the machine learning course. We already have labs, but in course we don't have any of the examples of good applying the algorithms, the stuff we are trying to apply on labs, on students, or on practice. And every time when I was learning any programming before, you first receive some example of good code, you put, how to say, a line trying to be similar. And would we have any kind of that in our math course?
I don't know. Not really. Okay, so please send me the contacts, those who want to participate in paper-like activity. Then we'll organize basically projects.
What is a cable-like activity? I heard the term, but I don't know specifically.
We take some example task from Kaggle.com. From our team and trying to get into leaderboard. Yeah. So we have 19 days before toxic comment classification challenge. That challenge, how to classify some comments. So it's not so much time to participate. I suggest that it's not a good idea to participate in that one. But there are some others. Landmark recognition, and you can choose.
Yeah, choose a
Should it be the only one for the whole group, or a group for few people?
You can group people for a competition that you choose.
Okay, from what number of participants then this kind of group becomes a group?
after.
Yeah.
It doesn't choose.
So I suppose 2 is enough. Okay. So 2. Yeah, so but comes to more than 6, 7. Yeah, and the competition I want to introduce is recognition of Rosette recognition. But we need to make some basic procedures before. We need some development to prepare such. We have some baseline to prepare. We have some funds to use. And in result recognition, the the whole task is to make the robot able to plug into the rosette. So we need to solve two tasks. First is rosette recognition detection task when the rosette is quite far from the webcam, and the second is to detect how to say calls. To detect specifically the shape of robots in closed view, to make robot able to possess make its position precisely. Okay, so the line is next week before public speaking training. You need to send what did you decide. Did you form a team? Will you participate or not? For those who will not, they need to schedule their presentations.
What would be like the acceptance criteria for these ones? I mean, we can try, but might not be able to.
Our common criteria is to acquire some skills during this activity. First is to get into leaderboard. Yeah, not develop top 10, top 20.
Maybe that's all. Yes, in the leaderboard, that's all.
With the score.
So, getting into leaderboard is just about how to understand task, how to form thought and send. That's all. The second, how to acquire specific skills, particularly for this task, and how to decompose the task, how to train neural network or other neurons. But let's, for example, you said that you need to spend about 100 hours of such 100 for a day, 100 reported activity. It's some kind of your experience. And after that, you can write in your summary, in your resume, that you have more than 100 hours of experience.
You need to provide the report after. You need to provide the report after.
Like last semester was like that.
Yeah, short report on that. What skills did you acquire during this?
But
What results you achieved?
But as detailed as the one we can do for business analysis, like stakeholder analysis.
No, you
More
just
general.
write that which technique works best. What obstacles did you face with and how did you manage?
Miniature law. Miniature law.
What?
I mean, you had bachelor qualification work, so it is the miniature bit for that specific project.
Sometimes. 100 reported hours. If there are 4 workers,
It would be better for them.
or misindicate mixed with open ending or coordination.
For each person, it seems to be very much. Just enormous time. What seems that?
Okay, for each person, not less than 40 hours. And yeah, for a team, not less than 100. Okay. Yeah, we need some procedure of acceptance of your report. Yeah? Because I'm not allowed to make cheating possible. Yeah? I mean, some judge procedure. If these hours really spent. So,
To record the video outside.
100 hours.
I don't know how to do it. You also suggest you may use Trello, deadline.
You could have 40 hours of screencast for everybody and then movement detection of it. If there is a movement for 40 hours, it seems to be work.
Really, we have such a request from our administration, from the university administration, to establish project uh, project activity among students. And the question is how to recognize real time spent on this project. How to authorize this? And I don't know.
It is actually expertise program that's been funded by 15 millions of rubles for now. And a big group of scientists is currently working on that.
Yeah.
So we will complete them.
Probably solution is that the task for the project needs to be not so simple.
Okay, but simple.
Yeah. That will guarantee that you will spend the work. Okay, so for now, that's all. If you have questions, suggestions, suggest.